Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Kirk Gray.
Hey, Kirk.
Hey, Fred.
One of the things, as we're talking about, various things in our lives and all the other good stuff, I noticed the other day that you got a webinar coming up with Hobbs Engineering, which is part of somebody who got bought by somebody else. So I don't know who's the owning, but it's a paid webinar, and you were talking about all the work you're doing to get ready for it. And I'm like, oh, we should talk about you talking about HALT.
Yeah.
Not that we've ever done that before. We've never talked about HALT before.
No, only about 25 years,
Yeah.
It's kind of like, it's funny to think this is a revolutionary idea that's been 20 years in existence ever since Gregg. As many people may not know, Hobbs Engineering is named and was created by Gregg Hobbs, who came up with the terms highly accelerated life test, which we all think is a misnomer, and it really should be referred to as a highly accelerated limit test.
Well, he all the good ones were taken. Like there was HP had a test that was similar to what he was doing, called Strife.
Right. Yeah. Stress plus life. Yeah.
Yeah. And so there, and then there's what is it? A highly accelerated over stress test, most or host or
no, that was after. That came after. Yeah, that was co-opted by somebody because that's sort of what HALT was taken. Well,
yeah, HALT was taken.
But Haas was taken. He couldn't just say accelerated stress screening which was ASS or something like that. He had to use a term, but the fact that he used life, he wasn't familiar with how traditional reliability engineering had made calculations of life, and everybody expected when you did a HALT process, you would come up with a life number, a life test.
That's right. So it's going to last 5 years with some amount of chance of surviving or whatever. And Gregg's philosophy, and I think it's fair to say you have, because you've told me over and over again, and it's really that you want to go find weaknesses and fix them. And then the product will be more robust. It will last longer because it is less sensitive to all the variations that happen in supplies and in manufacturing and use. And it's never intended to say, oh, this will last for 10 years. No.
Right. And I don't know, except for, there's things like automobile tires and batteries, and there are devices and electronics, IGBT that wear out.
The big
that you do have to worry about. And there are systems like energy systems now, the photovoltaic systems out in the field. It is very critical for them to know what the lifetime of those systems are. And that's important because with wind turbines, and they are expected in their whole economic basis of return on investment is based on the amount of time those can operate.
Yeah, if they don't last for 20 years, the upfront expense isn't worth it. So
exactly. And technological innovation, which is to me the drain in the bathtub curve for most consumer products, and a lot of, a vast majority of technical products is not relevant in that field in turbines. Once you get one up, you're not going to easily go replace it with a new model that's of 3 years.
It's not a software update you're going to do on one of these things to change the transmission.
Oh, that's change of the photovoltaics. Yeah. Also, we know the lithium-ion batteries. The CALS, University of Maryland, and Michael Peck's group is doing great work in analyzing and understanding the life issues.
The specific failure mechanisms. It's amazing. But so the other day, I ran, I was looking, I'm putting together a course on Ascendo. It should be out hopefully later this week, maybe next. It's the time we're recording. But one of the comments the instructor made was about all these, the issues with recalls and listed the consumer protection agency, or I don't know, it's CP National Transportation Highway Transportation Safety Administration, the FDA. They all have pages that are just recalls, alerts, notices, stuff like that. Yeah. And one of them, what caught my eye is that the whole page was covered in these off-road, it's sort of like dune buggies, but modern versions of them that were, I don't know, they all look like hopped up golf carts. It's good. And there's a whole page of them, all these different models that were photoed on, had images of them. And I'm like, what's going on with these things? Oh, the cable was routed the wrong way so that it'll wear with use and create a dead short. So the battery to the chassis. Right. Like, now you got a hot seat. That just, it's like, and you're not going to get vibration with this product, right? It's an off-road in all the ads, going over rocks and humpers and all that. And it was like, it was, and I started looking through the list, and it was manufacturing defects, faulty parts, counterfeit parts. It was, poor design, no margin, the kinds of stuff I was looking at it and then going, these are not wearing out.
And I'd say most if engineers go back, the ones that can access the failure root cause analysis of the failures of predecessor products in any company they're in, they would see that the vast majority of especially in commercial competitive industries or, highly like the phone industry or the computer industry, that the technological improvements in power and speed and all the other benefits, 5G, things like that. Everybody can't be using, we don't use anywhere near the life that's in these products. Mm-hmm. I have VCRs, we'll have DVDs. You probably have CD players. I don't know if any.
No, not anymore. I think I actually finally got. But well, wait, I do. My 1920 Tacoma pickup truck has a CD player in it, and my father-in-law had an eclectic collection of CDs that are just covered in grime and dust and dirt because they're just laying all over the place in the truck. So I don't know if that would be a stress test for the poor CD player when I stick in this, peanut butter covered dusty CD. But anyway, you've got this seminar coming up, and you were talking about...
it's coming up July 18th and 19th, I think. And so I'm coming up with a material. I'm trying to review everything that I've talked about over the last 25 years. And I'm trying to bring Gregg's ideas into it. And also, Gregg is the basis for all the direction he pointed me. I did change. I have modified some of the things. He wasn't always absolutely correct about everything, but he was generally correct about finding the weaknesses. And, I just posted on LinkedIn a thing about air fryers, 700 models of air fryers or something. There's some huge number of air fryers were recalled because of they were burning up.
Yeah.
Catching fire.
Catching fire. And not a good thing for a countertop oven.
And I know a thermal test to some limits, would have probably shown that. Yep. Shown the melting even the melting of a plastic maybe causing something to touch something else.
Right.
Which, in a product that it gets incredibly hot, you really have to go way beyond that. So anyway, it's costing these companies a lot more than whatever it would have taken to go take 10 of them and push them to a melting point and see what happens when somebody sets it on a stove. What happened
just if it's a hot day, or if it was in high ambient, or it was in the sun, or it had a strange load or whatever. But part of the issue is that, and that's, I think you were talking about as you're preparing this talk, is that a lot of people, I think there's there's three different ways you can approach product development from a reliability point of view. Well, 4. 1, just totally ignore it. Don't worry about it. You get what you get. And and you've known people, companies that's been their approach, and we see it, and sometimes it works just fine. Sometimes
it works. They're experienced. They do make products, and I've HALT tested products that don't really need any improvement. They've got fairly large margins.
Right. It happens. But then there's the kinds that say, well, we're going to go deliberately go find the weaknesses. That's HALT approach, and then we'll go fix that. And
we're going to go deliberately find if there are any weaknesses. Like I said, there's some that don't have.
And then we'll go fix it, and then we'll go do that. And then another approach is, we'll do a parts count prediction, and we'll do
worse.
We'll do a couple of fixed tests, and temperatures test to pass, so that we know it works, and make a bunch of assumptions, and we'll call it good. And then there's a fourth group that basically does the very detailed accelerated testing and understand their failure mechanisms and modeling. And you mentioned CALS and PEC. If you're doing a lithium ion battery and you're working with CALS, you've got all these grad students running tests for you. You got all this modeling capability going on. You really get to know a lot of stuff. But you can do the analytical approach, and if you do it well, it actually works. But it's constrained that it doesn't cover every failure mechanism. It covers dominant failure mechanisms if you know what they are. In HALT, it's great because it covers the vast majority of things that typically happen, except for the ones that cause it to fail after 20 years.
But you can only take into account the failure mechanisms and sometimes you don't know. In fact, a lot of times,
that's
the problem.
Yeah.
But also, you have to be able to model something. You have to have a consistent intrinsic behavior or intrinsic wear out or something that you're talking about.
Yeah, you have to know the failure mechanism. There's no doubt about that.
You have to know the failure, right? And you don't. And there's thousands of them.
And then the supplier changes the material in that polymer by, 1/8% and says, "Oh, it'll never notice," and now it melts or deforms.
The supplier changes the material, the
supplier changes the material.
Well, that can happen.
Yeah, but if you do all your testing, you do HALT, you do everything else, and it, you think you've got a good product, and then you go to production and they alter just one additive to it so that, and I've run into this where they said, we'll order to ramp this. We need to add this magic powder over here so that it does whatever. And now it doesn't work.
Right. Or a procurement guy says, we got a cheaper part and it doesn't work. Yeah. And he doesn't know that. And he didn't test for the margin in that.
But HALT is part of looking for the gist I'm getting from what your talk was and what prompted me to want to talk about it a little bit. To get back to, we got so much stuff we could talk about.
Well,
but one of the thoughts is that part of it is that you were talking about it is the different frame of reference.
Right.
So somebody thinks that if I just do what's in the standards, I'm good.
Right.
You and I both know that they're in big trouble.
No, that's the problem. All the standards and everything they know is not what's going to happen in the product that's going to cause failure. Otherwise, they wouldn't design it in. Yeah. The first rule of building in reliability is follow good design rules, okay? Good design practices. DFM, design for manufacturability. Use the same screws as much as you can, screw size. Don't, get a different, use the same kind. Anyway, there's just a lot to DFX, what design for. And that is a good design to get to time zero. It works on the bench. It works at zero. Okay. And then if you do have wear out mechanisms like a battery, then you can, that it will be important to know how long that's going to last as far as how many recharge and discharge.
And you can do a rough calculation though with that, where it just says, oh, we have this amount of capacity and we know from this style of chemistry that we get, X 100,000 recharges or however what the number is. And we can say, all right, this will last, if you have to recharge it every night, it'll last 6 days or whatever. You can get a rough idea and then you can go test that.
Right. But battery technology is also changing. So that's going to change too over time, that the batteries are going to get better and they're going to have to be remodeled. And you may not, it takes time to model that kind of stuff. And, you have to have experimental time at use conditions and compare that. And so all that takes time. But my biggest frustration, Fred, is the whole reliability industry, to me, has been built on quantification. And I did mention some products that do time quantification. That time quantification is critical, knowing the duration solar arrays, of wind turbines, of long-term systems, production systems. That if there are wear out, mechanical wear outs, gears, things like that in wind turbines, IGBTs, integrated insulated gate bipolar transistors do have a wear out. They will wear out in time, but we're seeing prognostics and health management do better measurements and precursors and looking for key performance indicators that will show that wear out mode, and they're getting to those kind of things. But Teslas and all the electric vehicles are going to have to use semiconductors that have tremendous power, is having to go to 100,000 watts to those wheels when you're accelerating, is quite a bunch of power, and that does cause a lot of heat generation, and over time for a car that's expected, and I think the lifetime of cars is probably expected to be at least 10 years. So that's a much longer term.
Yeah, and if you're replacing the IGBT and that inverter panel, that's not cheap. That's a significant expense. You want that to last a good long time.
Right.
And we know that IGBTs are Achilles heel of these these electric vehicles and solar arrays and everything else that uses that.
Quantification is important in some elements of a reliability of electric systems, in some elements of electric systems. We could also say electrolytic capacitors, aluminum electrolytics may have some wear out, but I haven't really seen that in a mini system being a problem that I know are quite old. So the vast majority, though, has been beliefs based on the 217 era in 64, whenever it came out. Yeah. And the orientation has been that, we can quantify this time that these things will live. And as you mentioned, with the manufacturing variations, with all the things that can occur during that dynamic period of production, over the life of production, anything can be introduced, and we've seen it. You've seen it, where a bad part is put in, a component that the manufacturer didn't know was damaged in shipping or handling or testing. It gets into the mix, and it really takes a lot of time and investigation to get down to that root cause. So some people just kind of, give up, and it's really hard because companies, people that, especially in design, that has a low margin, nobody wants to, everybody's trying to dodge the bullet. Who did this? Who missed this? Who overlooked? I'm sure the guy in Boeing that in the 737 Max MCAS system, saying that there was only one, based on one sensor, mechanical sensor outside the plane, the angle of attack sensor. Who missed that? Who kept overlooking that? Because it was just, when you look at it on the surface, it looks pretty obvious that relying on one mechanical sensor outside the plane to control a very critical operation of the, tail.
Well, when we talked about that before, it gets complex because, mechanical guys are saying, yeah, this thing works. And if it doesn't work, the pilot can override it. That's always an option. And then at some point they said, well, let's not tell the pilots.
Yeah, well, that was because of the training, the cost of training.
That's a different issue, and I was like, okay,
but okay, we, I can think of, I don't know, this air fryer, what was the problem with it, because you don't know. See, that's the problem. Another thing that keeps the field really restricted is the lack of sharing of.
Well, you should look at that website. I think I'll see if I can find it again. I'm pretty sure it was the Consumer Protection Agency or Consumer Protection something or another, and on their recalls page, and you can find those souped up golf carts, and it actually said the power cable was incorrectly routed during construction, and it wears and shorts to the chassis.
I think I told you I took in my Kia because of the same kind of thing they found out.
Oh, maybe they had the same thing, only different skin on the outside.
An engine module, or something like that, or it was controlled to the braking system. Something was very critical about it. But, maybe a very small 0.5%, who knows how many initiated this recall. But they had to go and either change out or call in, and that was quite expensive. But they could have probably found us out had they done a very high level, and I know they do in cars, but done it to a point of failure for this module. Mm-hmm. Or it could have changed. We don't know.
Yeah.
It could have changed. The design could have changed over time, like the ignition switch problem that didn't initiate the airbags. The guy changed the design, didn't tell anybody, didn't document it, and suddenly, they were seeing in the past a big problem with the previous cars.
But see, HALT's not going to catch these errors of judgment that are in the manufacturing process or a supplier's system or design, a rogue designer saying, "Oh, I'll just change this. This makes sense," and not doing due diligence for the effects. I mean, HALT has
not
a limited.
HALT is defined initial design limitations and weaknesses. Okay. Yeah. That's all it's really fine.
Right.
And you really don't want to find manufacturing flaws or errors in assembly or those kind of things, because you want what's the nominally manufactured product in the HALT. Okay. It's got
but most everything. And for your presentation, you've got tons of examples of finding stuff, and some you can talk about and some you have to obscure and all other stuff. But I suspect it'll be a lot of fun. Yeah. And we've talked about it in a handful of our shows, different things we've seen and found and so on. So you've got a couple of, sounds like you got almost 2 months now before you do your presentation. So you've got 25 years to distill in the next 2 months.
Yeah.
Down
really
to what, an hour, 2 hours.
Yeah. What I've seen and what I know. And also to address the very broad range of industry that I sometimes, from everything from, I've had seminars where everything from, the guys that make the neon or the LED signs, billboards, mm-hmm. to some at the same audience, somebody's making a breast milk pump for women. Yeah. And, it's just really hard.
But the principles apply. So I think that'll be fine for any audience. But if you tell an example that's on electronics, the guys in mechanical are tuning out and heading to the donuts.
Exactly. Yeah. And so it's really hard to keep everybody's interest. And I plan on focusing mostly on the principles, philosophy, frame of reference, and then kind of, the basic methodology, which, I cover sort of, but I've got to get them unhinged
like you.
I got to detach them from the idea that there are tests that can give you a lifetime field number. Okay.
I'm going to reference our very first podcast of Speaking of Reliability, number 1. It was over 758 episodes ago. It was on the question of, can you pass HALT? So we won't talk about it here because there's a whole episode on that one.
No. We've had lots of podcasts now that we've covered a lot of ground. So this is why after 25 years and, my knowledge and experience with the field and I still look at, reliability failures. I've got the news feed from Google on reliability issues. How many of these, are still based on things that could have been found if they tested to limits.
Yep.
And this is another thing, we talk about HALT. We don't talk about HAS.
Not as often.
But HAS is derived exclusively from HALT, and people don't understand that.
Yeah.
That you develop a screen, and it's usually as many stress factors stress stimuli as you can put in there in a chamber in a condition, and that is for monitoring ongoing and trying to catch those things depending on the risk your product has to failure in the field or the criticality of that system, that you would apply that because it is an expensive process.
That's a whole nother episode. So let's wrap it up and I want to leave it with the question of, now that we know that you got this to prepare and you got a lot of experience you're pulling on, but we haven't really gotten a ton of questions on HALT. We've got a few over the years that we've made episodes out of it, but here's our chance to, do two things. One is to get some feedback on what would people want to hear about in this seminar you got coming up. Mm-hmm. And then two is we could talk about it, flesh it out some here in the podcast so that during the next couple of months, you're still in the development process of this. So we could hash some of this stuff out here and get an answer out to people. So, head over to accendoreliability.com/go/SOR, and you can leave us a message. You can leave us a written message or a voice message. And we'd love to hear from you. In this particular topic, we've talked about it lots and lots of times. And we know that you're going to have a great audience and probably a handful of questions there. But here's your chance to ask some of those questions that help shape that seminar and add some content here, ideas for us to talk about during the show. So we'd really appreciate hearing from you.
Yes.
Sounds like you got 25 years and 2 months. That's going to be a challenge, but you can do it. You know what's important. So
I do. Again, I just hope I can at least give an initial paradigm and pointing a direction and a new frame of reference for my audience, and some examples of how they can, and they really do have to sell this if it's not a
it's not already in the house. Yeah.
No, there's many ways that you can, be able to convince management and the expense of taking this direction. Also, engineers that will constantly say, well, of course it broke.
You overstressed it. But that's episode number 4, I think.
Yeah.
We did that one. All right. So anyway, good talking to you, Kirk. Good luck with the prep, and we'll see what kind of questions we get to see if we can help what's on people's minds on this topic.
Okay. Thanks, Fred.
All right. Talk to you later. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.